Hello, good afternoon, student. My name is Hiral Rawat. Today's date 5th September 2020. Saturday, Standard 10, Subject Science. Chapter number 13, Magnetic Effects of Current. In previous lecture, we have studied many activities. We have studied the magnetic force line. So let's start. Magnetic field is a quantity that has both direction and magnitude. मैग्नेटिक जो फोर्स होता है उसमें डायरेक्शन भी होता है और मैग्नीट्यूड भी होता है. द डायरेक्शन ऑफ द मैग्नेटिक फील्ड इज टेकन टू बी द डायरेक्शन इन विच a north pole of the compass needle moves inside it. Therefore, it is taken by conventions that the field lines emerge from north pole and magnet at the south pole. Inside the magnet, the direction of field lines is from its south pole to its north pole. Thus, the magnetic field lines are closed curve. इसके लिए जो होता है उसका closed curves होता है. The reactive strength of magnetic field is shown by the degree of closeness of the field lines. The field is stronger, that is, the force acting on the pole of another magnet placed is greater where the field lines are crowded. No two field lines are found to cross each other. If they did, it would mean that at the point of interactions, the compass needle would point towards two directions, which is not possible. So topic 13.2, magnetic field due to a current carrying conductor. In activity 13.1, we have seen that an electric current through a metallic conductor produces a magnetic field amount around it. In order to find the direction of the field produced, let us repeat the activity in the following way. ये एक्टिविटी को पूरा उन्होंने रिपीट किया है. Activity 13.4. Take a long straight copper wire. हमें copper wire लेना है. 2 or 3 cells of 1.5 volt each and plug key. Connect all of them in series as shown in figure. उसको हमें सीरीज में कनेक्ट करना है. Place the straight wire parallel to and over a compass needle. Plug the key in the circuit. Observe the direction of deflection of north pole of the needle. If the current flows from north to south as shown in figure 13.5a, the north pole of the compass needle would move towards the east. Replace the cell connection in the circuit as shown in figure 13.5b. This shows that observe the directions of the direction of the north pole of the needle. If the current flows from north to south as shown in figure 13.5a, the north pole of the compass needle would move towards the east. Replace the cell connection in the circuit as shown in figure 13.5b. This would result in the change of the direction of current through the copper wire, that is from south to north. वो south to north में जाता है. Observe the change in the direction of deflections of the needle. You will see that now the needle moves in opposite direction, that is towards the west. It means that the direction of magnetic field produced by the electric current is also reversed. Here the activity. Okay, show the diagram. Activity 13, यहाँ पे 13.2.1 magnetic field due to current through a straight conductor. What determines the pattern of the magnetic field generated by a current through a conductor? Does the pattern depend on the shape of the conductor? We shall investigate this with an activity. We shall first consider the pattern of the magnetic field around a straight conductor carrying current. Here activity 13.5. Take a battery 12 volt, a variable resistance or a rheostat, an ammeter 0 to 5 ampere, a plug key and a long straight thick copper wire. Insert the thick wire through the center normal to the plane of a rectangular cardboard. Take care that cardboard is fixed and does not slide up or down. कार्डबोर्ड जो है वो स्ट्रेट रहना चाहिए. Connect the copper wire vertically between the points X and Y as shown in figure 13.6a in series with the battery, a plug and key. Sprinkle some iron fillings uniformly on the cardboard. You may use a salt sprinkler for this purpose. आप salt भी डाल सकते हो. Keep the variable of the rheostat at a fixed position and not the current through the ammeter. Close the key so that a current flows through the wire. Ensure that the copper wire placed between the point X and Y remains vertically straight. Gently tap the cardboard a few times. Observe the pattern of the iron fillings. आपको क्या करना है? कार्डबोर्ड को प्रेस करके जो पैटर्न्स है वो हमें देखनी है. You would find that the iron fillings align themselves, showing a pattern of concentric circles around the copper wire. What do these concentric circles represent? ये क्या represent करते हैं? They represent the magnetic field lines. ये जो है वो magnetic field lines को represent करते हैं. How can the direction of the magnetic field be found? कैसे हमें ऐसी direction मिलेगी? Place a compass at a point, say P, over a circle. Observe the direction of the needle. The direction of the north pole of the compass needle would give the direction of the field lines produced by the electric current through the straight wire at point P. Show the direction by an arrow. हम arrow से उसको दिखाना है. Does the direction of magnetic field lines get reversed if the direction of current through the straight copper wire is reversed? क्या ये जो कनेक्शन ये जो है वो रिवर्स हो सकता है? चेक इट, हमें उसको चेक करना है. What happens to the deflection of the compass needle placed at a given point if the current in the copper wire is changed? copper wire जो change हो जाता है तो क्या होता है? To see this, vary the current in the wire. We find that the deflection in the needle also changes. In fact, if the current is increased, the deflection also increase. करंट इंक्रीज होगा तो डिफ्लेक्शन भी जो है वो इंक्रीज होगा. इट इंडिकेट्स दैट द मैग्नीट्यूड ऑफ द मैग्नेटिक फील्ड प्रोड्यूस एट अ गिवन पॉइंट इंक्रीज as the current through the wire increases. What happens to the deflection of the needle if the compass is moved from the copper wire but द करंट थ्रू द वायर रिमेन्स द सेम, करंट जो है वो सेम रहता है, वो हमें देखना है। टू सी दिस नाउ प्लेस द compass at a farther point from the conducting wire. When change you do you observe? We see that the deflection of the needle decrease. डिफ्लेक्शन क्या होता है? डिक्रीज होता है, धीरे धीरे डिफ्लेक्शन जो है वो डिक्रीज होता है। Thus, the magnetic field produce the given current in the conductor decreases as the distance from it increase. Distance बढ़ता है। Figure 13.6, it can be noticed that the concentric circles representing the magnetic field around a current carrying straight wire become larger and larger as we move away from it. तो जो है वो लार्जर एंड लार्जर होता रहता है। Here the diagram. Variable resistance. This is cardboard P. Resistance R. वेरिएबल रेजिस्टेंस होता है तो उस पर एरो होता है ना। ये जो है वो रेजिस्टेंस है, वेरिएबल रेजिस्टेंस, एरो है। नॉर्मल होता तो ऐसे होता है आर। ओके, दिस इज मैग्नेटिक फील्ड लाइंस। ये डायग्राम किसका है? अ पैटर्न ऑफ कॉन्सेंट्रिक सर्कल्स इंडिकेटिंग द फील्ड लाइन्स ऑफ अ मैग्नेटिक फील्ड अराउंड अ स्ट्रेट कंडक्टिंग वायर. The arrows in the circle shows the direction of the field lines. A close up of the pattern obtained. हमें पैटर्न जो है वो देखने को मिलती है। Then another is right hand thumb rule. राइट हैंड थंब का रूल्स दिया है। हमारा राइट हैंड हमको ऊपर करना है। अ कन्वीनियंट वे टू फाइंडिंग द डायरेक्शन ऑफ मैग्नेटिक फील्ड associated with a current carrying conductor is imagine that you are holding a current carrying straight conductor in your right hand पर हमें लेना है, okay, and such that the thumb points towards the directions of current. Then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field as shown in figure 13.7. This known as the right hand thumb rule. ये जो है वो राइट हैंड थंब रूल हमें बताता है। हियर एग्जाम्पल 13.1, यहाँ पे एग्जाम्पल दिया है 13.1। A current through a horizontal power line flows in each to west direction. What is the direction of magnetic field at a point directly below it and at a point directly above it? यहाँ पे सॉल्यूशन दिया है। The current is in the east-west direction, applying the current is the east-west direction. Applying the right hand thumb rule, we get that the magnetic field at any point below or above the wire turns clockwise. वो clockwise जो है वो move होता है in a plane perpendicular to the wire when viewed from the east and the anti-clockwise when viewed from the west. clockwise करोगे और anti-clockwise हमें उसको जो है move करना है, okay. Here the inbuilt questions Topic 13.2.3 Magnetic field due to a current through a circular loop. We have so far observed the pattern of the magnetic field lines produced around a current carrying straight wire. Suppose this straight wire is bent in the form of a circular loop and a current is passed through it. How would the magnetic field lines look like? Magnetic लाइट जो है वो कैसे दिखती है? Here the diagram 13.8. We know that the magnetic field produced by a current carrying straight wire depends inversely on the distance from it. Similarly, at every point of a current carrying a loop the concentric circles representing the magnetic field around it would become larger and larger as we move away from the wire. बड़ा ही बड़ा होता जाता है, दूर जाता है, वैसे वो क्या होता है? Bigger in size. Every point on the wire carrying current would give rise to the magnetic field, appearing as straight lines at the center of the loop. By applying the right hand rule, it is easy to check that every section of the wire contributes to the magnetic field lines in the same direction within the loop. We know that the magnetic field produced by a current carrying wire at a given point depends directly on the current passing through it. Therefore, if there is a circular coil having n turns, कोई भी circular coil में suppose n turns होता है, the field produced is n times as large as that produced by a single turn. This is because the current in each circular turn has the same direction. जो डायरेक्शन होती है वो सेम रहनी चाहिए. एंड द फील्ड ड्यू टू ईच टर्न देन जस्ट एड्स अप, वो धीरे धीरे ऐड होता है. एंड 1 एंड 2 एंड 3 धीरे 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 वो लूप्स की जो स्ट्रेंथ है, वायर्स है, वो बढ़ते जाते हैं. स्टूडेंट, ये चैप्टर जो है वो पूरा जो है फिजिक्स से रिलेटेड है. ओके, फिजिक्स में जो है वो वायर्स होते हैं, है ना, पूरा इलेक्ट्रिक अप्लायंसेस का ये चैप्टर है. एक्टिविटी यहाँ पे दी है. एक्टिविटी 13.6 टेक अ रेक्टेंगुलर कार्डबोर्ड हैविंग 2 holes. Insert a circular coil having large number of turns through them normal to the plane of the cardboard. Connect the ends of the coil in series with a battery, a key and a rheostat. बैटरी के और rheostat के साथ वो कनेक्टेड है, shown in figure. Sprinkle iron fillings uniformly on the cardboard. Plug the key. हमें प्लग की जो है प्लग करनी है, मीन्स के उसको हमें अटैच करना है. टैप द कार्डबोर्ड जेंटली a few times. Note the pattern of the iron fillings that emerges on the cardboard. कार्डबोर्ड के साथ उसको इमर्ज करना है. ये जो है वो उसका डायग्राम है. ओके, ये जो सारी एक्टिविटी है ना, हम फिजिक्स लैब में कर सकते हैं. ओके, विक्रम साराभाई जो कम्युनिटी सेंटर है वहाँ केमिस्ट्री, फिजिक्स और बायो तीन की लैब्स है वो अवेलेबल है. बहुत सारे स्टूडेंट ऐसे होते हैं कि वो लैब में जाके एक्सपेरिमेंट करते हैं। आप भी वहाँ जा सकते हो। ओके स्टूडेंट, थैंक